morning everyone. So, in yesterday's lecture we were to calculate these 9 values: angle of incidence, sunrise sunset hour angle and day length, local apparent time, monthly average of daily and hourly global and diffusive radiation, and then hourly global beam and diffusive radiation under clear sky and solar radiation on tilted surface, right. So, we could calculate till here. So, monthly average, hourly global radiation. So, remember till now we have calculated only for horizontal surfaces, right. As we told earlier, the best method is to measure the solar radiation values using equipment, actual data. If not available, we can use the similarity between two locations and try to calculate the solar radiation values for particular places. So, even that is also not possible, then we use normally the correlations proposed by various researchers. So, our problem had two parts. The first part is we supposed to calculate angle of incidence. So, that we have reviewed. So, why we need the angle of incidence value, and then we also learned to calculate local apparent time corresponding to Indian Standard Time. Then the second part of the problem is for the average sunshine hours of 7.2 hour and elevation of the location above mean sea level is 14 meter. We were calculated the monthly average, daily and hourly global and diffusive radiation. That was our second part of the problem. Here we are going to calculate for tilted surfaces as well. So, while discussing the problem, we have also seen some of the concepts behind calculating each radiation values, right. So, now we will directly go to what we supposed to calculate and where we stopped yesterday. So, I think we stopped here. So, we calculated monthly average hourly global radiation. So, using the correlation proposed by Collares Pereira and Rabi and Guillemot. So, here we calculated the constant values A, B and F C. Using that we could get the relation between, this is I is always hourly. So, H is for daily. So, both if you want to take monthly average, that bar comes, right. So, this is what we have done here. In this formula it is nothing but Ig bar upon I naught bar, which is equivalent to Hg bar H naught bar, not equivalent to, it is proportional. So, that proportionality constant is, or the correction factor whatever we may call it, or fitting constant. So, that is nothing but A plus B cos omega upon Fc, right. So, the first researcher Collares Pereira and Rabi, so they told that we can simply take A plus B cos omega, that is enough. Then Guillemot said that there is another correction factor we supposed to include to match it with actual data. So, for that A and B is given here. So, here we use omega s, which is for horizontal surface, hour angle during sunrise or sunset, and I naught bar we discussed yesterday, and then we calculated Fc as well. Then from that value we predicted Ig bar is nothing but 2182 kilojoules meter squared hour. So, today we are going to see how to calculate monthly average hourly diffusive radiation ID bar. So, for that the proposed correlation is ID bar upon HD bar, which is equivalent to I naught bar upon H naught bar into A plus B cos omega. As I said earlier, the Liu and Jordan said that, so this itself is enough, right. So, there will not be any proportionality constant is needed, that means proportionality constant is 1, but again Satyamurthy and Lahiri in 1992 they proposed this particular correlation ID upon HD bar, which is equivalent to I naught bar upon H naught bar into A plus B cos omega. So, for that they said the constant A can be calculated based on the ratio of HD upon Hg. So, if this ratio comes out to be between 0.1 to 0.7, we supposed to use this particular formula. if the ratio is between 0.7 to 0.9, we are supposed to use this formula for A, and B is again function of B is a function of A, omega s, A and omega s, right. So, omega s we already have 93.32 degree, which is nothing but 1.628 radians, and for the local apparent time or solar time of 9 to 10 hours, we calculated omega is 37.5 degree, and I naught we just calculated yesterday, right. I naught is around 3871. So, that value is given here. So, kilojoules per meter squared hour. Then Ig value we have calculated 2182 kilojoules per meter squared hour. Then HD value, so yesterday's calculation also we have chosen the HD value calculated from Modi et al. So, that we have given here. So, kilojoules per meter squared day, because it is a daily average, and H naught we already calculated 37957 kilojoules meter squared day, and Hg bar, that also we have already calculated kilojoules meter squared day. So, we have chosen April 15th. Why? Because we supposed to equate I naught to I naught bar. So, all the values are given. So, we supposed to calculate what is the ratio between HD bar upon Hg bar. So, HD is given as 9825 upon Hg, which is nothing but 21213. So, which is turned out to be 0.4631, right. So, then we supposed to use the first formula. So, A is equal to 4922 plus 0.27 upon 0.4631. So, this is 1.0751. So, remember, when you calculate these values, we sometimes take 2 digits, sometimes take 3 digits. So, in that way, when you calculate, there will be minor difference in these value. So, the way you calculate, for example, somebody calculate this ratio first and then add it, somebody do it directly, and when you are using this value for further calculations, so you may use the whole value instead of making it to 2 digits or 3 digits. So, in that way there would be small variations. For example, if I am getting 999, you may get 1001 as well. So, please do not worry about that, right. And then we supposed to calculate B. So, B is nothing but 2 into 1 minus 1.0751 and sin omega s in degree 93.32 minus 1.628, which is omega s, and cos 93.32 upon 1.628 minus 0.5 sin 2 into 93.32. So, if you calculate, so your B would turn around minus 0.097. So, we calculated A, we calculated B, then we go back and substitute in this value, right. So, ID is 1 we supposed to calculate. So, I naught, that is 3871, H naught, that is 37957, and then A is 1.0751 plus B minus of 0.97 cos omega is 37.5. So, if you calculate, your ID is 999 kilojoules per meter squared hour. So, we calculated monthly average hourly diffusive radiation. So, all these values, right. So, what is that? Hg, HD, Ig and ID. So, all are calculated for the horizontal surface, horizontal surfaces. Okay. So, the next one is hourly global beam and diffusive radiation, Ig, Ib and Id. So, this is under clear sky. So, how do we define this clear sky? Because nowadays we have sophisticated instruments to calculate the values exactly, but still these correlations were proposed long back, but here we are making ourselves comfortable how to calculate, how to get these data. So, these data to calculate, so what are all the parameters we would be requiring, right, if the actual measurement of solar radiation values are not available, right. So, this particular formulae or model is proposed by ASHRAE. So, this is American Society of Heating, Refrigerating and Air Conditioning Engineers. Okay. And also if we remember the ASHRAE, so this particular model is proposed based on US data, right. So, to calculate here, if you see, we need A, B and C, the constants, right. So, here we have A, B, C. So, this is proposed for over the year, right, but it is for the year, but each month will have different constants, right. Throughout the year the constant won't be same, because we know the climatic conditions and the water vapor content, because these constants are used to calculate beam radiation as well as diffusive radiation, right. So, the water vapor content and the dust in the atmosphere and the sun and earth position, because that also changes throughout the year, right. So, all these three constants are function of all these things. So, because of that each month they proposed different constants, and also it is totally based on US data, but still we use this here to learn about how to predict the global radiation using their model, right. As I said earlier, so this is for particular day they have given in the year April 21st, these three constants are available, A, B, C. And if you see here, the A constant is nothing but flux, right, watt per meter square. So, this we supposed to convert into kilojoules meter squared hour. So, in that case we supposed to convert, right. So, what is joule per second meter square. So, we supposed to multiply and divide by 3600 to make it to joule meter square and then hour, right. And we supposed to calculate this as a kilojoules as well, right. So, 4068 and we multiply and divide by 1000 as well, right, because we supposed to get the values as kilo. So, we have to divide by 1000 as well. So, in that case you would get 1130 would be converted into 4068 kilojoules meter squared hour. So, B, C constants are unitless, so that we do not bother about that. So, the beta value is not required at all here, right, because we are still calculating for horizontal surface only, and omega is 37.5. So, lat we have taken as 930 hour. So, for that the delta is 11.57. Why delta we supposed to calculate? So, now it became April 21st. So, April 21st is nothing but 1/11th day of the year. So, we supposed to substitute 111 here. So, and then calculate delta. So, that is 11.57, and we would require here cos theta z, right. So, that is we still calculate for the same location. So, sin 19.28 and sin delta is 11.57 plus cos 19.28 cos 11.57, omega is 37.5. So, if you calculate, so your cos theta z is nothing but 0.7998. So, from this we will calculate the hourly beam radiation IB, which is equivalent to IBN cos theta Z. So, IBN is nothing but the beam radiation in the direction of sun rays. So, IBN we supposed to calculate, again we need IBN for this. So, IBN we are going to calculate using the ASHRAE model. So, A e power minus b upon cos theta Z. So, it is nothing but exponential decay of the beam radiation, right. So, we have here A is 4068, that is A, and then e to the power minus b minus 0.164. So, cos theta Z is 0.7998. So, if we calculate, this is IBN. So, this is becoming 3314 kilojoule per meter squared hour. So, if we substitute IBN value here, so IB turned out to be 2650 kilojoules per meter squared hour. So, IB we calculated, ID is nothing but C into IBN. So, IBN value we already have, C is nothing but 0.120, IBN is nothing but 3314. So, how much ID we get is 397 kilojoules per meter square hour. So, if we add IB and ID, then what you get is IG. IG is 3048 kilojoules meter squared hour. So, here we used the US data. So, what we can do is we can get actual data of Indian climate and compare both, right, how much IB value we get for a particular location and how much ID value we get. So, there based on the US data we are getting beam radiation as high and diffusive radiation as much as low, but based on the Indian climate maybe diffusive radiation would be high and beam radiation would be low, but they compensate each other, and probably we might be getting global radiation is same around. Okay, so we can always compare and check whether that particular model would be able to calculate these global beam and diffusive radiation under clear sky. Solar radiation on tilted surfaces. So, here the formula is total radiation which is falling on tilted surface, which is equivalent to IB RB ID RD plus IG, which is nothing but IB ID RR, right. This we have seen in the lectures already. So, this is divided by IG throughout, because we already have the values of IG as well as ID, that is global as well as diffusive radiation. So, we wanted to convert in terms of ID and IG. So, this is IB, IB can be written as IG minus ID upon IG. So, this becomes 1. So, 1 minus ID into RB plus ID upon IG into RD. So, IB plus ID, which is nothing but IG. So, this becomes RR. So, to calculate that we would require that conversion factor or tilt factor. So, RB, RD and RR. So, RB is as we discussed in the lecture, it is cos theta I upon cos theta Z. So, I is nothing but angle of incidence, Z is nothing but zenith angle. So, we have all the parameters. Sin delta is 9.42, sin 19.28 minus 30 plus cos 9.42 cos 37.5 cos 19.28 minus 30. So, this is cos theta I, and cos theta Z is nothing but sine of 9.42 sine 19.28 plus cos 9.42 cos 37.5 cos 19.28. So, if you calculate, this value is coming around 0.9316. So, we have calculated RB. So, this bar refers to monthly average, and RD and RR is very straightforward, 1 plus cos 30 upon 2, which is nothing but 0.9330, and RR is rho, which is 0.2, is taken for concrete surfaces, into 1 minus cos 30 upon 2, which is 0.0133. So, we have RD ready, RR ready and RB ready. So, then we supposed to substitute in the equation IT upon IG, which is equivalent to 1 minus ID upon IG into RB plus ID upon IG into RD plus RR. So, this particular value is 1 minus ID upon IG. So, this value is given here. So, ID is 999, IG is 2182, 999 2182, RB we calculated as 0.9316 plus ID is 999 upon 2182, RD we calculated as 0.9330 plus 0.0133. So, from this we calculate IT as IG is nothing but 2182 into this total value. So, if you calculate, your IT is coming around 2063 kilojoules per meter square R. So, this value is also calculated as kilojoules per meter square R. So, this value is also kilojoules meter square per hour. So, the same way you can also use the correlations to calculate on a day basis, right, which is daily basis as well. So, daily basis also formula is same, HT upon HG into 1 minus HD upon HG RB plus HD upon HG RD and RR, right. So, but if you see the way we calculate RB, that is tilt factor for a beam radiation, that is different for calculating on daily basis. So, here we have that omega ST also in place, right, and omega S also is in place. So, that we have already. So, for omega ST is 88.20 and omega S is 93.32. So, we supposed to substitute here. So, RB is here, omega ST we supposed to substitute in radians. So, 1.539 sine 19.28 minus 30 sine, our delta is similar, right. So, April 15th. So, 9.42 plus cos 9.42 sin omega ST 88.20 cos 19.28 minus beta, beta is 30 upon omega S, which is 93.32. This is degree, but we supposed to substitute in radians. 1.628 sin 19.28 sin 9.42 plus cos 19.28 cos 9.42 cos 37.5 sin omega S 93.32. Okay. So, if you calculate, your RB is coming as 1.11, RD is same right, whatever we calculated previously, 0.933. R is also same, which is 0.0133. So, then we supposed to calculate H T bar upon H G bar, which is 1 minus H D bar H G bar into R B bar plus H D bar H G bar R D bar plus R R bar, right. So, here we have H G and H D in place. So, H D is 9825, H G is 21213 into R B, what we calculated is 1.11, H D is 9825, 21213 into R D is 0.933 plus 0.0133. So, how much H D you would get is this total into H G is 21213. So, H T what you get is 22089 kilojoules meter square day. So, this is total flux falling on daily average basis, right. So, in this way you would be able to calculate the H T, that is total flux falling on a tilted collector, which is the total radiation of beam, diffusive and reflective radiation. So, that is all. So, we learnt in this particular lecture to calculate various solar radiation values using correlations and formulae presented in past 2 classes. So, here we have listed out the references. So, these 4 references were used yesterday. So, today we used Leo and Jordan, right. So, another journal paper, and Satyamurthy Lahiri we used, and ASHRAE, which is Handbook of Fundamentals, that particular model to calculate the beam, global and diffusive radiation under clear sky. So, these are suggested references, and all the formulas and the correlations you would get from Suhatme and Nayak, Solar Energy Principles of Thermal Collection and Storage. Thank you.